Okay, let me just double check, make sure this is recording. I want to double check before I go any further. Okay, I am recording. And all right, here we go. It's only my third time doing this, so let's hope we get it right this time. Okay, solving equations with logarithms. So solving exponential or logarithmic equations. I told you this is where some of you are going to start having problems. If you've been keeping up on things, that's going to make things much easier for you. If you haven't been keeping up, it's going to catch up to you. So let's hope that you've been keeping up to this point. So first of all, number one, rewriting the original equation in a form that allows you to use the one-to-one properties. Now, we've done that a lot with exponentials already, making the bases the same. And those were the non-calculator problems. Let's look at another one for logarithmic functions while we're at it. Let's actually jump down to a problem here. Let's take a look at question D here, example number 3, part D. Okay, this is a log equation. Now you could change it to exponential form, and you could use a property. Actually, I haven't taught you the property, but just so you're aware, just in case this comes up, b to the log of base b raised to the x power equals x. That is a log property. You don't need to know it, but if you see it somewhere, that is true. So you could use that. However, common sense. A log base 3 is equal to a log base 3. What can you tell me that must be true? Common sense. It's equality property. If the bases are the same, the arguments must be the same. Otherwise, they can't be equal to each other. So I'm going to subtract x. I'm going to add 1. And then I get an answer of x equals 2. And you can check your answer. When I plug in 2, I get log of 9 base 3 equals log of 9 base 3. Now some of you are going to say, oh, I could just guess and check and do that in my head. Again, show your work. What are you doing in your head? You're not guessing and checking. You're using the equality property. And each step is equivalent to the previous step. Show good mathematical work in order to receive full credit. Okay, so that's the equality property for logs. We did the equality property for exponentials when we made the bases the same. So that's the equality property. Number 2, rewrite an exponential equation in log form and solve. So let's look at exponential equations. These are exponential equations because the variable is in the exponent. So for exponential equations, we need to change them to log form. However, you have to isolate the power first. And when I say power, I don't mean exponent. I mean the power. That is a power. A base with an exponent is called a power. So you have to get that by itself first before, whoops, don't do that. It's not 3x, it's 3 raised to the x. Equals 5. Now we can change it to log form, and we've done that quite a bit, so hopefully log of 5 base 3 is equal to x. A log is equal to the exponent to which you raise the base to equal that number. All right, now calculators. We can use the change of base on our calculator, but it didn't tell us to use the change of base. So I'm going to show you on your calculators, and again, Every calculator is a little bit different, so get used to your calculator. When I say calculator, I don't mean say 3x equals 5 and plug it into Desmos and have it solved. That's not what I mean. You're going to take this exponential equation, you're going to solve for x, and then you're going to use your calculator. Log of 5 divided by log of 3, ln of 5 divided by ln of 3. Or, most calculators nowadays, and then on the TI-84s, if you go to math and you arrow up, it says log base. And it allows you to change the base and not have to use the change of base formula. Now, use the change of base formula if that's what the question asks you to do, just like we did in the previous homework. If this does not specify that, so use any method you want. Once you get x by itself, you can type this into your calculator, any method that is correct. And we're going to round to 3 decimal places. So x is approximately equal to 1.465. Okay, next one. Exponential equation. Isolate. So 4 to the 2x minus 1 equals 22. Change to log form. The log of 22 base 4 equals 2 to the x minus 1. If you don't know where that came from, you need to go back to rewriting equations. Now we can use our calculator. Okay? This is going to be approximated with our calculator. And in your calculator, again, you can go back, you can try it now, or you can go back and try it later. Log of 22 base 4 is 2.2297. So I'm going to set that equal to 2x. I'm going to add 1 and divide by 2. And again, this should be approximately equal to, because we did round from our calculator. So that's approximate, that's approximate. So x is approximately equal to 1.615 if you type it into your calculator correctly. Okay? So before, when we did these, we were able to make the bases the same and use the equality property with no calculator. There is no way to make these bases the same, so you can change them to log form and use your calculator. I recommend. Okay? Let's take a look at B. Let's do all of the exponentials first. Exponential equation. Isolate the power by subtracting 5. Change to log form. A log is equal to the exponent. So that's base E, log of 55, base E equals x. But what is log base E? What's another way of saying log base E? It's the ln of 55. And if you type that into your calculator, you will get x is approximately equal to 4.007. Now, if you ask a math teacher to do this problem, they are not going to change this to log base E and then ln. That's not how they're going to do it. Okay? So when you get used to doing a lot of these, there's something that shows up. And here is something that you should think about. If your power has a base E, and you have a base E equation, take the natural log of both sides. If left is equal to right, then the natural log of the left is equal to the natural log of the right. That is true. Now, why would I want to do that? Because natural log of e to the x, this is something you should know. Natural log of e to the x is just x. And I get the same answer. That's how most math teachers would do that problem. Okay? I don't care if you do it this way. I would recommend doing it this way. Just show your work. Okay? Now, having said that, if this was a base 10 problem, this was a base 10 problem, I would take the common log of both sides. Okay? That's what I would do. Just like if it's a base e, I take the natural log of both sides. So keep that in mind. Okay? So if we go back up to these examples, this is not a base e, this is not a base 10. This is not a base e, this is not a base 10. If you really wanted to take the natural log of both sides, you'd still get the same answer. If you want to take the common log of both sides, you'd still get the same answer. Let me show you real quick. The natural log of 3 to the x equals the natural log of 5. The x comes out in front using our log properties, and then x is equal to the ln of 5 divided by the ln of 3. And when you type that into your calculator, that's the same thing as the log of 5 divided by the log of 3. That's the same thing as the log of 5 base 3. You will get the same answer. So that's another way of solving an exponential equation. But a lot of people don't like multiple ways. Just tell me one way and only one way. So if you're one of those people, to solve an exponential equation, always change it to log form and you won't get confused. That always works. Okay? However, let's look at part C. How do I change this to log form? The log is equal to the exponent. Well, which exponent? This one or this one? So this is a special case of exponential equations. Okay? Can we make the bases the same? These are the things, these are all the things that you need to go through in your critical thinking. And that's why it's confusing for some people, because there's so many things to think about and they get confused. So if this was a non-calculator question, these bases, the 4 and the 5, would have to be able to be made the same. They do not have a base in common, although some people think their base in common would be 20. Base 4 and base 5 do not have a base. They are not a base number. There's no base number they have in common. So you can't do that without this problem without a calculator. Okay? And again, I don't mean type this equation into decimals and this one into decimals and tell me what the solution is. It's not going to work. You have to show me your work. So the special case for exponential equations that have two variables in their exponents, you are going to take, you're going to do it similar to this one over here. You're going to take the log of both sides. Okay? You can take the natural log, which means ln, or you can take the common log, which means log. It's completely up to you. I always use the ln. It's not base e, it's not base 10, so anyone, no one is better than the other, ln or log, your choice. The only reason I use ln is because we use it all the time in calculus, and it's one less letter than log. That's really the only reason. Special case. Now, this exponent, we can use our power property for logs, and we can move it out in front of the logarithm. Same thing with this exponent. And now you need really good algebra skills to solve for x. Just like you need really good algebra skills to get through calculus. And I know I talk about calculus all the time. That's because I know where you're going to go and what you need to know and what difficulties kids have in calculus. And a lot of the times, it's not the calculus, it's the algebra. Okay? So, just to review, exponent on both sides that have a variable. This is a special case. Take the log of both sides. Move the exponent out in front because that's a log property. Why do I do that? Well, because I'm trying to get x by itself. And there's two of them. So the only way I can do that is to get them on the same side. So now I'm using the distributive property. Okay? Again, I'm trying to get the x by itself. I have to get them on the same side in order to get that x by itself. So I'm going to subtract the x ln of 5 from both sides, and I'm going to move the other terms to the right side. So I'm going to add ln of 4 to this side. I'm going to subtract x ln of 5 from both sides. Now they're on the same side. And now I can factor it out. 2 ln of 4 minus ln of 5, 2 ln of 5 plus ln of 4, solve for x. How? Divide 2 ln of 4 minus ln of 5. And now practice typing that into your calculator. That is the exact answer. The calculator will give you the approximate answer, 3.959. I would recommend, again, make sure your calculator is up to date. Alpha y equals number 1 makes it much easier to type in fractions into your calculator. So that's a very challenging algebra problem that you should know how to do. Maybe practice that on your own. So that's solving exponential equations. We had a special case where it was base e, so I took the natural log of both sides. We had another special case where I had a variable and two variables in the exponent, so I took the log of both sides. Those are special cases. Okay? If they're not special cases, it would look like A and B. All right, moving on to log equations. How do you know you have a log equation? Well, because there's a log in the equation. To solve a logarithmic equation, you change to exponential form. Again, you should know how to do that. Take the cube root of both sides, and the answer is 5. Simple enough. Okay, next one, single log. Change it to exponential form, solve for x. How do we solve for x? Again, for those of you who don't know, the 1/2 power means the square root of x to the 4th. What do you do to both sides to get x? You square both sides. And you should know how to square a fraction without a calculator, square the top and square the bottom. Okay? And just a reminder, you're solving for x on these, which is your base. Your base can never be negative, and your base can never be 0. So if you got that answer, that would be wrong, or there would be no possible answer if that's what it worked out to be. Okay, no solution. Your base is never negative. Your base is never 0 on logs. Okay? So that's the general idea for log equations. But let's take a look at this one. This is a log equation changed to exponential form. However, you may need to use properties of logs to condense the log to a single expression, or try to isolate the logarithm. So let's see if we can isolate the logarithm. That means, can we get it by itself? Can we get this all by itself? Sure we can. 2 ln of x, subtract 5 from both sides, you get -1. Divide both sides by 2. Single logarithm, a 1 in the front. Remember, 1 in the front, otherwise you can't change to exponential form. Now we can change to exponential form, and you get e to the -1/2 equals x. If you type that into your calculator, that's approximately 0.607, round to 3 decimal places. Okay? Jumping to E, a log equation. This 2, as well as this 2 up here, that can go up into the exponent, but avoid making it your exponent, because you'd have to take the square root of both sides, and then you're going to have to worry about plus and minus, and it just causes all types of problems. So don't move that up there unless it asks you to condense. If I can move this somewhere else, I would. So I'm going to just divide both sides by 2. That's your best bet there. Single logarithm, a 1 in the front. Now I can change to exponential form. To solve a log equation, you change to exponential form. So you have 25 equals 3x, and x equals 25 divided by 3. If they asked you to round to 3 decimal places, that would be 8.333. Notice, each step is equivalent to the previous step. That's how you show work in math. Make sure you show your work. Remember, I'm not a mind reader. Okay, last one. A log equation, because it has the word log. Isolate the log. Well, there's 2 of them. So, in order for me to make it one of them, I have to use my log properties. The sum of a log is the log of the product of 5x times x minus 1. You're taking the log of the product of the arguments. That is the product property for logs. Now I have it written as a single logarithm. Now I can change it to exponential form. What's the base? 10 raised to the second power equals 5x times x minus 1. 100 equals 5x squared minus 5x. How do we solve for x? What kind of equation is this? It's a quadratic equation. I've seen some crazy things. I've seen people take 5x and set it equal to 100 and x minus 1 and set it equal to 100. You can't do that. That's bad math. That's only if that was a 0 can you do that. Okay? So quadratic equations, you should know the first thing you do for quadratic equations is to get everything to one side. And then you could use the quadratic formula. You can factor, you can complete the square. I always love factoring. Favorite F word, right? So I'm going to try factoring first. Check for a greatest common factor, the one thing that many people forget. And it does factor into, that would be minus 5 plus 4. So set your factors equal to 0. 5 never equals 0. There's no solution on this one. X minus 5 equals 0 equals x plus 5. And x plus 4 equals 0 equals x equals negative 4. So we have two solutions, but as I told you earlier, you should check your answers. Okay? Because you cannot have a negative base. So if it was negative, there would be no solution. You also cannot take the log of a negative number. So when I plug in 5, I get 25. When I plug in 5, I get 4. So that's the log of 25 plus the log of 4, which is the log of 100. Is the log of 100 equal to 2? And the answer is yes. So that one works. Let's check negative 4. Plugging in negative 4, I'm taking the log of negative 20. It's not possible. Plug in negative 4 here. I'm taking the log of negative 5. That is not possible. So I'm crossing this answer off because it's extraneous. That means it's an extra answer. I'm crossing it off because it makes my argument negative. Not because it's negative, but because it makes my argument negative. It's not that I can't have negative answers. I can't have negative arguments because I can't take the log of a negative number. And I also can't have negative bases. So those would be no solutions. Those wouldn't work. Okay? All right, so that's the notes for solving exponentials and log equations. And we're going to be practicing those. And hopefully we'll get better at it.